Assalamualaikum and hi to all students. Okay, so today I will continue on this lecture 8. Okay, basically on the topic of hypothetical testing to mean and one sampling testing. Okay, so you can refer to the file that I have already uploaded at UKM Folio. Okay, so as we go on this topic, okay, so basically on this topic, the one that we need to understand, okay, is about the principles of hypothesis testing. Okay, and then when we want to do this hypothesis testing, of course we have to have some statement, okay, whether we want to reject or do not reject. This is something that is quite common in hypothesis testing. So what is this all about? So that's why on the second one, state the logic and the change the statement to the null and alternative hypothesis. So the null, okay, is H null. Okay, so we can write it as H null, and alternative is the opposite of that null hypothesis. Usually we write this as H1, or you can write it any notation that you want to put, as long as it is referring to alternative hypothesis. Okay, and the next is what is meant by type 1 and type 2 errors, okay, when we involve on this hypothesis testing. Okay, and of course in doing hypothesis, we have step by step to guide you on how we want to conduct this hypothesis testing procedure. Okay, and then after step by step, we'll continue with examples on how we want to conduct it, and then we determine and explain the p-value for the test statistic. So basically, what is hypothesis? Okay, hypothesis means explanation pertaining population parameter. Okay, so we have learned previously on population, and we have population mean overall, right? We have population, we have sampling, and now we're talking about population. Okay, so population mean is the one that we have also learned previously, and it is on the mean of that particular population, not sampling, the whole one. Okay, and you see that you can refer to the previous notes. The difference, maybe you can refer to the notation on writing the population for, mean for population and also for sampling. Okay, and then there is another one which is population proportion. Okay, proportion means part of it. Okay, ratio from that population, maybe from the whole one, proportion of particular item or specific category from the whole population that you want to take out. So that is proportion. Okay. So just now I've mentioned on stating null hypothesis. So if you see that this is the notation of null hypothesis. So this is a statement about the population parameter value. Okay, statements that are being tested about population parameter, the thing that you want to test about that population parameter. So we will go on explaining about what is null hypothesis, what statement that you can describe when you want to test about the population parameter. Okay, so we look at this example. The average screw diameter is 30 mm. Okay, so when you see the example statement that is written here, the average screw diameter is 30 mm. So we can write that the null hypothesis. So you know that the average screw diameter, average means is the mean, right? So the average is the mu equals to 30, because the statement states the average screw diameter is 30 mm. So you understands that it's talking about mean, because average. So it is about population parameter rather than sample statistics. From just now, we have already mentioned and emphasized that it is on population. Okay, so it is about population parameter rather than sample statistics, and that's why you see in this red circle here. Okay, as I said to you, population and sampling. We have the difference on the notation, right? So you see it is written here as mu and not as x bar. If you notice that both of it means the same thing, mean and average, but it's just that because we want to differentiate. Okay, this is on population, not sample. Okay, so it's just a matter of notation. I hope that is clear on that. Okay. Okay, so the next one is on alternative hypothesis, H1. Okay, contrary to the null hypothesis, as I mentioned to you also just now. Okay, for example, the statement that is mentioned just now is the average diameter of the screw is not equal to 30, because the statement initially on H null, okay, it states that the average diameter of the screw is 30, right? So on the null hypothesis, it is contrary, means opposite of the null hypothesis, so it's not equal. If the H null is equal, so your H1 or alternative of it is opposite, not equal to 30. So you can write it as H1, so your average not equals to 30. So alternative signs is not equal to. Okay, and may or not be proved. It depends. After you run the steps by step on this hypothesis testing, you get the statistical and critical value, then you compare. So then we decide, okay, whether to reject or do not reject the H null. Okay. Okay, so this is the error that usually involved in decision-making hypothesis testing. As I said to you, when you make the hypothesis testing, it involves on decision-making, decision whether on the to reject, do not reject your H null. Okay. So what is this type 1 error? Okay, we have two types here. Type 1 error. Okay, you reject the null hypothesis when it is true. Meaning that when your null hypothesis, or for example, just now, your H null is what? The average of the screw diameter is 30 mm, right? So when your H null, which is when the screw diameter is equals to 30 mm, is true, but you go and reject the null hypothesis. So this is type 1 error. Okay? Which means that when you do not reject the H null, but you did go and reject. So basically you are making a mistake. Okay, the statement is true, but you reject. Okay, so this is a type 1 error. Okay, you reject the correct H null. This is the other way of saying it, of type 1 error, and it's a very serious type of error. Okay, so the probability of type 1 error is alpha. It is called the level of significance for the test, and it is assigned by researchers because it depends whether you want to put it at 5%, 3%, something that you are tolerable of. Okay. And type 2 error. Okay, but usually in the question of exam or test, it will be given to you. Okay, the alpha. Okay, so the next one. What is a type 2 error? Okay, type 2 error happens when you fail to reject the null hypothesis when it is wrong. Okay, for example, okay, again, the H null that we are referring to this in this video, okay, the H null is saying that the average diameter of the screw is 30 mm, right? So basically, we assume that this null hypothesis is not correct. Actually, when after you perform the hypothesis testing, you get the value. Actually, we need to reject, which means that actually the average screw diameter is actually not equals to 30. But you fail to reject null hypothesis when it was wrong. Okay? So this is type 2 error. Okay, failure to reject incorrect H null. So basically, how you want to have some understanding and memorize on this error in decision making. So if you look at type 1 and type 2 error, basically it is talking about all about H null. Okay, so type 1 is something that when it's true, you reject. Okay, type 2 is basically when it's wrong, you fail to reject. Okay, so one is talking about true. So when true, actually you have to accept, right? But you reject. So that's type 1 error. And looking at type 2 error, okay, when the null hypothesis is actually wrong, but you go and accept, or we can say it as fail to reject. So basically one is talking about when it's true, you do not you reject, and type 2 when it's wrong, you do not reject, but you go and accept. But usually in hypothesis testing, Okay, we always say do not reject and reject. We didn't say accept. We said reject H null or do not reject H null. And that's why you see in this type 1 and type 2 error, we didn't say accept. We say what? You reject the null hypothesis when it is true. But basically, what you need to do is you need to do not reject when it is true. Okay? And also to type 2 error, you fail to reject. Okay? Which basically is do not reject. Okay? Fail to reject. Sorry, not do not reject. You need to reject when it was wrong. Okay? But then you fail to reject, which means that you do not reject the null hypothesis when it was wrong. Okay? Because when it's wrong, you cannot take it. So you have to reject when it is wrong. Okay? So that's why I said to you, type 1 and type 2 error is basically on H null. Okay, H null only. So that is how that I can explain to you and help you out. Okay, on you to have a better view to understand this both type 1 and type 2 error. So it is all about your H null. Okay, hypothesis. Okay, you can see that in this table, basically it's talking about the same thing. It's just that they simplify in this table so that you can have a better view, I guess. Okay, so possible results of hypothesis exam. So you see that now it is basically about H null only. So in real situation, when H null is true, okay, the result do not reject H null. So no error because do not reject H null. Okay, means you accept, right? When it is true. So no error. So probability is 1 minus alpha. So this is the right decision. So it falls under type 2 error because you do not reject H null when it is wrong. So it falls under type 2 error. Okay. And then reject H null. Okay, when you reject H null when it is true. So this called as type 1 error probability. And opposite happening to your H null when it is wrong. Okay. And basically, in relations of type 1 and type 2 error, it does not happen simultaneously at a time. So cannot happen both at one time. Only one. That's why it's not simultaneously at a time. So type 1 error applies only if H null is correct, and type 2 error applies only if H null is incorrect. That's why I said to you, it cannot happen both at one time. Only either one only. Okay. Okay, so before we start on statistical testing of this hypothesis test, right? So we look at this on how do we want to know, how we want to decide the decision making. Okay, so we look at this bell shape. Okay, and we can have a better view for you to have a better understanding. Okay, on when you want to reject, when you want to do not reject. Okay, so this is basically on the previous lecture, we already talked about sampling distribution, right? So how the data is scattered, is distributed. Okay, so the sampling distribution for the statistical test, it is divided into two, namely the rejection area and receiving area. Receiving means you do not reject, so you take it or you receive it. Okay, so if you look at this graph, okay, the one that is in between this critical value in this area, okay, is the accepted area. And other than this, which means that if this is larger than this critical value, so we reject. Same goes to here on the left side, which is where usually it's on negative lah. So if the value is more than this critical value here, so any value of this that falls under this area, it is on the rejection area. So this gives you a hint on how you want to decide. Okay, after you did the hypothesis testing, after you get the critical value, the statistical value, you need to decide. Okay, so why this is rejection area? Because it's too far away from sampling distribution mean. So it's too far and it's like it's not that accurate. It is far scattered or distributed. So hypothesis test for mean, okay, we're talking about mean here or the average. So hypothesis for mean, Okay, we have two types here. If in the question is given to you, okay, your sigma is known, so you use z-test. So z-test also we have learned previously on how we want to conduct, how we want to read the table, right? And then the second one, if it is unknown or not given to you, so we use t-test, and we need to refer to, of course, t-table. So basically, z-test for hypothesis for mean, for your average. If your sigma is known, so you need to change your statistical sample of your x bar to statistical test, which is z-stat. So still remember this in your previous lecture. We have learned on how to convert this, okay, into the z-stat value. So we use formula x bar minus mu and divided by your sigma divided by square root of your n, or number of observation. Okay, so basically, this is a step involving in a critical value approach for testing. Okay, so the two-tail test. Two-tail, you know, the mean is you have the value on the right side. Okay, if you see at the table just now, I'm sorry, the graph just now, this is two-tail. Okay, two-tail. Okay, change the sample stat. So the first step, from x bar to the statistical test. Determine the critical value of z for the predicted alpha level from the table. So you need to refer to z table. And decision rule, if statistical test is within the rejection area, okay, this is rejection area, okay, reject H null. If otherwise, fail to reject means do not reject H null. Okay, if you look at this slide, two-tail test, okay, this is the one that I basically draw just now. Okay, if you see at this bell shape, and because it's a two-tail, right, there are two critical value or cutoff, okay, indicating the rejection area. So you see that this is one tail, this is another tail. So if it is fall in this within area, we always say do not reject, which means that we accept. Okay, so in this area. So if falls, if the value, let's say it is falls within this area or this area, so we need to reject your H null. Lower critical value, upper critical value, and if it's fall under this area, which is this, so we do not reject or we accept. Okay. Okay, so these are the steps in hypothesis testing. First, as I mentioned to you just now, determine the null hypothesis, of course. So it depends on the question. Okay, and of course, the alternative hypothesis, you need to have this in guiding you on how to make the decision. And then select the level of significance. Of course, this is needed, okay, because you want to read from, because alpha is needed. If you have two tail, right, you have to need to have this alpha value in order for you to be able to read the table, right? So the third is determine the statistical test. Of course, if it's known or sigma is unknown, so you need to use Z or t-test, sorry. So that's why you need to determine what test you need to conduct, Z or T. Okay, the fourth one, determine the critical value and divide the area of acceptance and rejection area. Of course, like we have seen in the previous slide, we have the rejection and the acceptance, or we do not reject area. So there's the guidance on you to decide after you conduct the hypothesis testing. Okay, next, collect data and calculate values for statistical tests. You make statistical decision and management conclusion if the statistical test is in the non-rejection region, so we do not reject. Okay, so it all depends on what is the value that you get. Okay, and then you can make your own conclusion. Okay, now we look at the example of a hypothesis exam, okay, for testing Z if your sigma is known. Okay, test the fact that the actual mean diameter of the screw is 30 mm. So now they assume that your sigma is 0.8. So which means that it is known. Okay, so you see the first step, determine the null and alternate hypothesis. So you know that the statement given to you is what? The actual mean of the diameter of screw is 30 mm. So you know that your H null of the population mean with that we denote as mu here is equals to 30. Alright, so of course, when you want to provide your alternate hypothesis, of course, it is the opposite one, which is what? which is your H1 or your H alternative, okay, of mu here is not equals to 30 because it is opposite of your H null hypothesis. Okay. So you have 1 equals and not equal to. Alright, okay, the second step. Determine the level of significance. So we assume that your alpha is 0.05. Okay, the third one, determine appropriate techniques. Okay, this is the one I mentioned to you because it is known, right? So we use Z-test. So you know that you need to read from Z table. Okay, after that, determine the critical value. How you want to determine the critical value? How you want to get the value from the Z table? That is the critical value. So you know that your alpha is 0.05. So you go and read from your Z table to get this plus minus 1.96. Okay, I don't need to elaborate further because I think that this is well explained in the previous video and previous slide. Okay, okay, and the fifth step, collect data and calculate statistical tests. Okay, now once you have the critical value, which is the value that you get from the Z table. Okay, so assume the sample result is, so now, of course, this is given also in the question, n equals to 100, which is the observations. Okay, and then x bar here is 29.84. okay, your x bar given in the question. So now your sigma is equals to 0.8 because you assume that it is known. Okay, so statistical tests are, okay, Z stat is the one, critical value is the one that you get from the table. Alright, statistical test, which is the one that you calculate from this formula of Z stat here. So that's why you go and plug in the value of x bar here into this equation, which is 29.84 minus with mu. What is mu? 30. Alright, so and then you plug in of the sigma value and also n, and you'll be getting your statistical test of Z stat here is negative 2.0. Okay, so you have your critical value, you have your statistical test value. So now we want to decide. So we look at this graph again. Okay, so basically you can sketch of this to get a better view. Okay, then that helps you to understand or not whether to reject or do not reject, which area does it fall into, right? Okay, so we look again. Okay, I mentioned to you, this is the one that is critical value. Critical value. What is the critical value that you get of when your alpha is equals to 0.05? Of course, you know this is a two-tailed test. So you need to divide your alpha into 2. Okay, this is also have been explained in the previous slide. I hope that you guys can refer to the video again and make some revision. Okay, because this has already been explained over and over again. Okay. So you see that because it's two-tailed, right? So alpha divided by 2. From what? From 0.05. So you get 0.025 here. And the other tail, 0.025. Alright. So from this alpha value, you can refer to Z table. So this is the critical value that you get. Of course, because two-tail, one is on the negative side. So it's negative. Because you get plus minus, right? So one is on positive, so it's 1.96. Alright, so this is on your critical value. Critical is the value that you get from the Z table. Alright, so now you know your benchmark here, whether if the one that you get from calculation, okay, the area is fall in this do not reject, so we do not reject, which means we accept your H now. But let's say the value is falls into this area on the positive side or this area on the negative side, so you know what you need to decide. Okay, so now we refer to the Z stat you get just now. What is it? Negative 2.0, right? Negative 2.0. So negative 2.0, is it in this area or this area? Of course, it is on this area, right? So what is it? It is in the area of rejection now. So this is how you've been guided on how to decide of your hypothesis testing. Okay, so because your Z stat is less, because it is here, negative, right? Then negative 1.96. So statistical tests are in the area of rejection. Okay, so basically on this slide, it's the same thing, the graph. So just now, it's already been calculated for you, 0.05 divided by 2. So basically, this is how they get 0.025 just now. Okay, so now just do an interpret decision. It's the same thing like the previous slide, it's just that they write it on in a better way lah. So it shows that this is less than, so we reject H now. Okay, because we reject here, and conclude that the mean diameter for screw is not equals to 30. Why you can conclude it? Because you know that what is your H now? H now is your average of your diameter for screw is equals to 30, right? So when you reject your H now, which means that you take your H alternative, which is the mean diameter for screw is not equals to 30. So this is how you make your decision. Okay, next, p-value approach for tests. P-value is the probability of getting the same or more extreme statistical test than the sample statistical value, assuming your H null is true. So how confident are we in rejecting H null hypothesis? So p-value is actually the observed level of significance. Okay, so H null is rejected if p-value is less than alpha. Okay, so we're going to see how we want to so p-value approach, compare p-value with alpha. So if your p-value is less than alpha, you reject H null. So if opposite, do not reject. So this is your guidance on to make your decision when you are using p-value approach. Okay, so this is the steps of using p-value approach. So basically the first step is the same thing also. You need to determine your hypothesis null, alternative. And second also is quite the same, level of significance alpha. And of course, sample size are also needed to be described. Third, determine the appropriate test statistic and sampling distribution and collect data and make statistical decision and management decision. So on this step, this is the one that you need to refer on whether to reject or do not reject. Okay, if your p-value is less than alpha, so you minus, okay, H null instead of rejecting H null. So we're going to see on how to do. Okay, so now we look at the example on hypothesis test using p-value. Okay, so basically we're using the same example. Okay, so just now also we use the same thing. That's the fact that the mean diameter of the screw is 30 mm. And we assume that your sigma is equals to 0.8. So if you see that basically we start off with the same thing. The first, your H null hypothesis, your H alternative hypothesis. Okay, and the second one is also quite the same. Alpha of your level of significance and sample size. Okay. And then we need to determine appropriate statistical test. So basically this is also quite the same, which is we use Z-test because of your sigma is known. And then the fourth step also quite the same because you calculate or convert this into using this formula, statistical test value, which is you get the same thing also, negative 2.0. Okay. Okay, so how do we get this 0.0228 value here? Okay, calculating p-value, use table Z normal. Okay, so see again here, you calculate, the critical value that you get here is negative 2.0 and this is on the positive side, which is 2.0 here. So you open your Z table and we go and refer to the value of your Z equals to negative 2.0 and negative 2.0 and positive 2.0. So you'll be looking at, because this is negative 2.0, right? So the value, you look into the row of negative 2.0, you'll be getting 0.0228. This is from the table. Okay. So of course, once you get the value here, which is negative 2.0, you get 0.0228. Okay. Alright. So on your left hand side here, okay, you calculate here, which is 0.5 minus with 0.4772 here. So you still be getting 0.0228 here. Okay. So you can get this value from your Z table of 0.0228. So it's the same on the left, negative, and also your positive side. Okay. So your p-value is actually from both of this value on your your left tail and your right tail. Okay, so you plus both ones that you get from negative side and also from your positive side, so you'll be getting the p-value is 0.0456. So remember that this is only the steps to calculate for your p-value. You need to compare it with your what? Your alpha. Okay, so we move to the next slide. Now you already know that your p-value, after you calculate that, you get 0.0456, and you know that whether you need to reject or do not reject, it depends when you make the comparison with your alpha, right? So what is your alpha? The one that you already described in the first step. Your alpha is 0.05. So 0.0456 is actually less than 0.05. So your decision is to reject your H null. So this is how you conduct hypothesis test using p-value. So you can use the first step or the first approach or this second approach. Okay. So basically, the one that I've explained just now is how you want to conduct hypothesis test, okay, when your sigma is known. And there are two approaches, either from the Z value, Z table, the other also from Z table, but basically we refer to the p-value. So there are two approaches, but basically either approach that you choose to use, you will be getting the same answer. You should be getting the same answer. It's just that the approach is different. Okay, so done with that. So now we move to the next hypothesis test, because remember just now I said to you there are two statistical tests, right? Z and also T. So now when your sigma is unknown, okay, so we use the student T distribution instead of Z distribution. So when using the T distribution, the populated population is normally distributed, but if it's not normally distributed, then the sample size must be big enough. So this is also have been explained in the previous lecture and slide. Okay, so now we move on how we want to conduct this test. Okay, but basically the steps, concept, and how you want to decide is same as the Z distribution. It's just that you refer to T table, and on the formula that you want to get the statistical value, you use for T statistic. Okay, so now we look at this formula. Change the sample statistic of X bar to T statistical test, which is X bar, your T stat equals to X bar minus mu, and you use this into sample, okay, sample statistic here, because you do not know your sigma, okay. So that's the difference. Alright. So we look at this first example. Okay, when your sigma is unknown. So the average cost of hotel accommodation in Kuala Lumpur is 168 per night. So to prove this, a random sample of 25 hotels was taken. So you have your N here. And given the decision, X bar was 172.5 and S is 15 ringgit and 40 cents. So the hypothesis tests that the average cost of hotel accommodation is different from 168. Difference, okay? At alpha equals to 0.05. So you have this 0.05, and you see that assumed population distribution is normal here. So it is already assumed that it is normally distributed here. So that's why you can proceed with the statistical test. Alright. Okay, t-test for two-tail. So now, when you read the case study that they gave you just now, so you see that, of course, the first step, you need to know your H null, your H alternative. Alright, so of course, the H null is equals to 168 and different, right? Different, not equal lah. Different means not equals to 168. Right, so this is also already described, and then this is given, right? Alpha equals to 0.05. Okay. And is also given in the question. So now, because you use T table, okay, again, T table and how you want to read from the T table also I have already explained to you, and in the previous lecture. I hope that you can do some revision on this. Okay, of course, T table involves degree of freedoms. So n minus 1. Okay, so your n is 25. So UDF is 25 minus 1, which is 24. Settle with that. Okay, of course, this is two-tail, right? So remember that your alpha need to be divided by 2 on the left side and right side here. Okay. And then you need to know this is the rejection area, acceptance area. Okay, so How you get this? This is critical value. The value that you get from your t-table. T-table here, this is your df. Okay, this is your alpha. So you can refer to t-table. You should be getting this value. Alright, so I'll skip explanation on how to read from t-table because this have been learned in the previous lecture. Okay, so we go to the next step. So now we know that your sigma is unknown. So that's why we use t-test. So of course we use t-statistical formula here. Alright, so we just plug in the information that is given in the question. So your x bar in the question is 172.50. So your mu is actually 168. So you just plug in. And you know that your S is equals to 15.4 and this is your N value. So this is your T statistical value, 1.46. So you need to refer back to this graph. Okay. 1.46 falls into this area. What is this area? Do not reject area. Okay. So you do not reject H null because your T stat is fall in this area. Okay, that's why you need to have your critical value to have some guidance on you to decide. Okay, so conclusion, not enough evidence to state the actual cause of the cause is different from 168 because you do not reject H null, which means that your H null is true, which is your actual cause, okay, is 168. Okay. Okay, so just now is two tail test, one tail test. Okay, in many cases, so just now you see that your alternative hypothesis is not equals to. So it is fall into two tail, one in negative and right side. Okay, so in many cases, alternative hypothesis can focus at only one direction also, which is one tail test. Okay, for example, if you see here, your H now is more than or equals to 3 and H1 is less than 3. So this is a lower tail test because the alternative hypothesis focus on the bottom end of mean, which is less than. So one tail. So if you see here, this is more than, right? So this is upper tail because the alternative hypothesis focus on the upper limit of mean, which is more than 3. Okay. So we look here when involve only one tail. So remember, if one tail, you need to know is it lower or upper tail test. So now we look at lower tail test here. There's only one critical value because the rejection area is only at one end. One end only. So what is the end? End of lower, which is on this side because it's less than 3. So important, alpha is not divided by 2 here because you only involve only one tail, which is lower tail. So let's say if your alpha is 0.05, so 0.05 it is. You don't need to divide by 2 because this involve only one tail, one side only. Okay. Same goes to upper tail test. Upper tails means because this one is more than, right? So your alpha also no need. You don't need to divide by 2. If it is 0.5, then 0.05 it is. Okay. So there is only one critical value because the rejection area is only at one end, which is what? On your upper tail or your right side, which is the positive one. Okay, so now we look at the example here. T-test of the upper tail for mean. Okay, if your sigma is unknown. Okay, because this is basically on t-test, so of course your sigma is unknown in this particular category. Okay, so if you look here, that phone industry managers consider the monthly phone bill has increased and now it's over 52 a month. The company wants to test this statement on alpha equals to 10%. So construct hypothesis testing first. So we know that your mu is less than or equals to 52, average not more than 52. Okay, so it states here that it's over 52. So your H alternative is more than 52. Average exceed 52 ringgit per month. Okay, so this is what? This is upper tail because it's more than 52 here. Okay, so for this one tail, which is upper tail, okay, so now we know that this sample is N25, X bar is 53.1. Okay, so you plug in into this T statistical value here, 53.1 minus with what? 52. Okay, and you divide it by this one, this S, which is 10, and your N is 25 here, so you'll be getting your T statistic is 0.0. So this value is assumed to have x bar 53.1 is given in the question lah. Okay, if we assume that your x bar is 53.1 because we assume that it's exceed 52 here. Okay. So now we need to interpret the decision. So you know that this involves only one tail. So what tail? Upper tail, right? So you need to focus on this area. So the one that you calculated just now is what? Is you get 0. I think that you get just now is 0.55 T-stat. Okay. So now from your critical value, T-stat is 0.05, 0.55. So T-stat is something that is the one that you read from your T-table. So this is the one that you should be getting 1.318. So 0.55 in the area do not reject H now. So it is evident that the mean bills do not exceed 52. Therefore, manager's claims are incorrect. Okay, because you do not reject H now. Okay, means that it is not more than 52 here. So this is how you decide using the upper tail. Okay. Okay, now we look at the hypothesis test for proportion. Okay, so when we talk about proportion, it's always on the desirable category, okay, of that variables. So that's why it involves category variables. And it contains two possible results, desired criteria or does not contain the desired criteria, the one that you prefer or do not prefer. Okay, so part of proportion that is desired, okay, is denoted as pi here. Okay. Proportion. The proportion of the sample in the desired category is P. Okay. P equals to what? The proportion, right, equals to the numbers of desired category in the sample divided by sample size. So when X and N minus X are at least 5, the P of proportion approximates normal distribution with mean and standard deviation. Okay. So this is the one that involved in proportion. So it involves P. Okay, mean for proportion equals to pi here, and sigma of proportion is equals to the square root of pi, okay, 1 minus pi divided by n. Okay. So how we want to do hypothesis test for proportion? Because just now we conduct hypothesis test for mean, right? Okay, so normal distribution conditions, x must be more than equal or equals to 5, and your n minus x must be also more than or equals to 5. So that is the conditions. So the sampling distribution for P approach normal, we use the Z test of Z-stat here. Okay, so this is the formula involved here. Z-stat, okay, so your P, okay, of your proportion, which is your x divided by n, right, minus with your pi, and this is your basically your sigma P here, sigma of your proportion here. Okay, so Z test for proportion. Example, a marketing company said it received feedback from 8% of its customer. To test the statement, a random sample of 500 customers was reviewed with 25 feedback. Okay. Test at the significance level of alpha equals to 0.05. So you check the condition. First, your x equals to what? 25. So it's more than 5. Now, your n minus with x, which is your 500, right? Your n minus with your 25 here, which is 475. So it's checked more than 5. Okay. So Z test for proportion. Okay. So of course the first one is your H now, H alternative. So we use not mu here because it's proportion, right? So we use your pi here. So it is equals to, just now it is mentioned in the question that is 8%. So basically it's 0.08. That is the desirable category or proportion that you want to conduct. So the alternative is the opposite, which is not equals to 0.08. So your alpha is basically 0.05, your n is 500, and your p is 0.05. Okay, so you just plug in the formula, okay, inside the Z statistical, which is your p equals to 0.05, right? So minus with your pi 0.08, and you plug in here. So this is the one that you get from calculation, which is negative 2.47. Okay, and of course you need to have your critical value here, but you know that you're using Z, right? So you need to refer for what? For alpha divided by 2 area, which is on the negative and positive side. So you get your alpha equals to 0.05 divided by 2 here and divided by 2 here. Okay, So you'll be getting negative 1.96 and positive 1.96 here. So now, the one that you get from your calculation here is negative 2.47. So it falls into this area, which is what? Rejection area. So you reject H now at alpha equal to 0.05. Proven rejecting company statements whose feedback rate is 8%. Okay. So again here, calculate p-value and compare with alpha. So this is on p-value. So p-value again, you refer to the Z table of this negative 1.96. Okay, 1.96. You read from your Z value negative 1.9, right? And you take into 0.6. 0.6, if you read from the table, you'll be getting 0. This is negative 1.96. So 96. Okay. So this is the area here. If you read from the exact table, so p-value here is actually p-value equals to 0.0136 here. Okay. Of this value. Okay, sorry. So for this calculate p-value here, okay, because we take from the one that you calculate just now, not negative 1.96, sorry, it's from your Z calculate, which is negative 2.47, right? So you read from your table negative 2.4, okay, and you read along the row, you'll be getting at negative 2.47, you'll be getting 0.0068 on your left tail, and on your right tail, of course, the same thing. So you just times with 2, because basically if 2 tails, you just times the same value. Okay, so you'll be getting 0.136. So remember, we do not take from this, okay, 1.96, but we take from the one that you calculated just now for p-value, okay? And then you compare with your alpha. So what is your alpha here? 0.05. So basically this is obviously this is less than 0.05. Okay, so you reject your H now. Okay, so that is all for this chapter, and I hope that my explanation is clear enough to help you out to understand on this chapter 8. Okay, and all the best to all of you. Okay, stay safe, stay at home. Thank you.